Today, we're going to be talking about indefinite integration, which is a very important topic in calculus. What is an indefinite integral, otherwise known as an antiderivative? In calculus, an indefinite integral is a function, capital F, whose derivative is equal to the original function f. F prime x equals fx. The symbol for integration is shown on the presentation. Every time you're integrating, you will see this symbol. It's also called an antiderivative because it's the inverse of a derivative. Properties. Some basic properties include the integral of ax dx equals a times the integral of x dx when a is a constant. This just means whenever you have a term with a constant in it, you can take the constant out. Next, we have the integral of a large polynomial. On the slide, it shows the integral of x cubed plus 3x squared plus x plus 1 dx. This is just an example. Basically, whenever you have a polynomial with multiple terms and you're looking for the integral of it, you can take the integral of each term individually. Moreover, whenever you solve an integral, you need to add the constant of integration, which is usually represented with a capital C. This is because when you take the derivative of a constant, it goes to 0. So when we're taking the integral, we don't know if there is a constant or if there's not. Therefore, we have to add the plus C. Find an integral. There are many methods used to find indefinite integrals. However, in this video, we will be talking about the two of the most common and most useful. Number one is the reverse chain rule, otherwise known as the reverse power rule. Number two is U substitution. We're already very familiar with the regular chain rule used in differentiation. If fx equals x to the n plus 1, then the derivative equals n plus 1 times x to the n. Thus, for integration, we can see that the integral of n plus 1 to the x to the n dx equals x to the n plus 1 plus c. Furthermore, since n plus 1 is a constant, we can divide that from both sides to get the integral of xn dx equals x to the n plus 1 divided by n plus 1 plus c. This is the term we're looking for. For the first example problem, which is x cubed dx, we can see that reverse chain rule is applicable. X to the n equals dx equals x to the n plus 1 over n plus 1. So in this case, n equals 3, and we can plug that into our formula. Therefore, the integral of x cubed is x to the 4 over 4 plus c, which stands for the constant of integration. Furthermore, for the next one, we can split up the terms using the basic properties of integration to find that the integral of x cubed plus 1/7 x squared equals the integral of x cubed plus the integral of 1/7 x squared. We can use the reverse chain rule on x cubed and x squared respectively to find that the integral is x to the 4 over 4 plus 1/7 times x cubed over 3. When we simplify this, we get x to the 4 over 4 plus x cubed over 21 plus c. Another way of solving complex integral problems is with U substitution. We pick U, which is a random variable, and set it to represent a function inside of the integral. We want U to simplify the problem. Then we differentiate U and set du equals the derivative of U times dx. We rewrite the integral. Instead of using dx, we use U and du, and we integrate with respect to U. And finally, we substitute U back in the answer to get our final result in terms of x. Look at an example problem that uses U substitution to quickly solve the problem. We see that the most complicated term in the integral of 6x times 3x squared plus 1 to the 8th dx is 3x squared plus 1. So we can set U equal to that to simplify the overall problem and make the process to solve it easier. Then, using the steps showed in the previous slide, we differentiate U to find U prime equals 6x. Therefore, du equals 6x dx. We substitute U in to find we're now looking for the integral of 6x times u to the 8th dx, which is equal to u to the 8th du when we substitute du in for dx. Solving this integral we use reverse chain rule to find the integral of u to the 8th is u to the 9 over 9. Now we can substitute in u equals 3x squared plus 1 to get our final result of 1/9 3x squared plus 1 to the 9 plus c. Make sure you include the constant of integration. Thank you for watching. I hope you enjoyed this video.